In this video series, we're going to be looking at how to use Inventor, and I'll be showing you guys a brief tutorial, some tutorial videos on how to use some of the basic tools. Now, these videos are quick overviews of the tools you'll need, but really the best way to get good at Inventor and being able to draw the parts that you'd like to draw is to really play around with it, because practice is always important, and you're really not going to get a grip on this sort of thing unless you draw. Secondly, there's a lot of resources out there that give more in-depth tutorials on certain tools. So perhaps if you watch the video on how to scale an object and you get the gist of it, but you're still a little confused, you want to go a little deeper, you want to see what else you can do with that tool, well, there's plenty of resources online, including a Lynda series on how to use Inventor. And Stony Brook University has a subscription to lynda.com, so you can go through their whole tutorial set of videos, and they're going to be a little more detailed. So if you want a little more detail, you can go to lynda.com. You can use Inventor's help screen. It's pretty good. You could also go to YouTube, and there's tons of stuff on YouTube on how to use this. But hopefully this is going to be a good place for you guys to get started, and I think you'll find it helpful. So before we get into Inventor, let's talk a little bit about your project. You guys will be making a robot, and this is really exciting. And in previous years, teams have been entirely responsible for assembling their own parts for the robots. But now you guys have an opportunity to design your very own parts specific to your robot design. And you're going to design these parts in Inventor, and you'll send them over to us, and then we'll send them to a laser cutter. And this laser cutter will manufacture your parts, and then we can give them back to you, and you guys can assemble your robots. Now, the laser cutter was used to manufacture the same parts you assembled your homework robot with. So you can see an example of what that would look like. And we will be supplying you with the CAD files for your homework robot. So it should be a really nice example as to how a CAD drawing turns into finished product from the laser cutter. Now, essentially how laser cutter works is you have a stock piece of material at a given thickness. We will be working with 3/16 of an inch acrylic. A laser comes down and cuts out of the material the geometry that you've drawn in your file. So your third dimension is restricted by the thickness of your material. So in this case, all the parts that you guys will get for your robot are going to be 3/16 of an inch thick. So this process is a little limiting in that, and for example, a 3D printer does not limit you in the third dimension. However, a laser cutter definitely has its own advantages. One being it is magnitudes quicker than 3D printing. The first is a laser cutter is a lot quicker. Manufacturing something like a gear in a 3D printer could take hours, but a 3D printer can cut that same gear in 3 or 4 minutes. So there's definitely its pluses. Now, let's just take a look at an overview of how the process works, a little flowchart I have here. So this is an example of a computer drawing that I had made in the past. It's a screenshot of an object I've had in Inventor, and this is a wheel. It kind of looks like the Google Chrome symbol, and I've drawn it, and I wanted to attach it to a robot I was building at the time. I had this 3/16 inch material, and finally here's the laser cutter itself. Combining all these three things together, you get these parts. This computer drawing corresponds to the top left part here, and you can see they really are cut directly out of the stock material. This kind of hopefully will help you visualize what the 3D process, what the laser cutting process looks like. Now let's go into Inventor. And I don't want you guys to worry about following along. This is just an intro. All the how-to videos are going to be coming up later on. So, but this is somewhat should resemble the screen that you get when you open up Inventor. Now, Inventor is a computer-aided design, or CAD software. And what you can do with softwares like this is create clear and well-defined parts that are easy to edit and that you could send over to a manufacturer so they can produce it, or a engineer so that they can review it. And you aren't just limited to parts. You can create multiple parts, and you can create an assembly of parts, or you can even create an entire machine. But we're just going to stick with part files for now. Let's click on New, and we have 3 part files here. We also have assembly and drawing files, but we're going to exclusively work with part files. Now, you can see we have 3 different sort of part file formats here. We have the Mech 101 template, which we've created specifically for this class, the sheet metal template, which you should not use, and the standard .ipt template, which is acceptable, but you just might not find as convenient as using the Mech 101 template. So let's just select the Mech 101 template. You can download this template online. We've provided it to you. Now, you can see that this template already comes with the 12 by 12 rectangle that you guys will have to fit all your parts inside. So, the one thing I do want you guys to take away from this video, the only technical thing I want you to take away, is that to enter a sketch that's already been created, just double click on it. Well, don't double click on the name, double click on the icon. And now we're in the sketch, and we know we're in the sketch because it says finish sketch up with a little check mark, and that's only there when we have an option to finish the sketch, and we know that this sketch is also green. That means we're good to go with our drawings. So here's something that we could make if we wanted to just make a wheel, for example. Don't worry about following along. I'm just showing you an example. We could make a 2-inch wheel that has a shaft size of 0.16, and that is 0.16 is going to be a very common number that you'll see going around, because that is the size diameter that fits the number 8 screws that you've been provided. The number 6 screws can also fit inside of it. They're a little loose, but it's also 0.16 is the size for the blue Vex hinge joints that you guys will be given. So now we've made a wheel, and maybe this is a wheel you would want to use for your robot. So when you send us the file, just take all your drawings that you've created and move them into the 12 by 12 rectangle. And then if you were to send us this file, we would cut this wheel for you. And you just continue this process. Now, this is not required, but just so you guys know, if we wanted, we could make this wheel 3-dimensional. Inventor has the ability to do that. We can make it a 1/4 inch thick, and you can see if I rotate this, well, we now have a wheel with some thickness. However, it's not necessary to specify a thickness of 3/16 of an inch, because that is already implied by the manufacturing process of laser cutting. We've limited that 3rd dimension to you. So in many cases, dimensioning this thickness is very important, but you guys don't have to worry about that. So just keep all your parts to all your files that you send us to 2-dimensional files, and you'll be good to go.